So welcome back. Today I want to show you about the normal distribution in the note that I'm about to upload today. This is also another distribution that is used to calculate probabilities for continuous variables, but before you can use it, you need to do something called standardization process. Now standardization process is done this way. You say that Z is equals to X minus mean over the standard deviation. You will be given these variables, all of them actually. So the first thing is you standardize. Now the normal distribution looks like this. It's a bell-shaped curve. Now you can see that right at the middle we have a 0. Now when you standardize, you'll be getting the values of Z. Now there is a table that gives you the areas between 0 to that particular value of Z. Your work is just to read the table and see. For example, if you get the value of Z is 2, 2 will be somewhere here. So you just go in the table. Then because 2 is positive is here, you read that value. That value will be the area between this 0 to that 2. Even if the value is negative, like negative 2, just go to the table. The table does not give you negative values. Just go and read 2 again, even if it is negative, and that will be the area between 0 and 2, and that will be your probability. Let's have an example here. We have this equation is still in the online platform. We have a sample of students has a mean age of 35 years and a standard deviation of 5. A student was randomly picked from a group of 200 students. Find the probability that part 1, he lies between 35 and 40, or lies beyond 45, or lies below 25. Now to answer question 1, the first thing is you standardize, where you get the value of Z. Now Z is equals to X minus mean over standard deviation. In the first case, where X's here are 2, 35 and 40, the first value of Z is going to be 35 minus 35 over 5. You get it as a 0. Then for the second value of Z, which is 40, 40 minus 35 over 5 is 1. So what we are looking at is the area between 0, the area between 0 to 1. But from our normal distribution table, you'll find that when I come here and I find 1 here, which is 1.0, you can see here the area is 0.3413, and that now becomes our answer in that case. For the other case where we are told beyond 45, now what does beyond 45 mean? Beyond 45 implies that you get the value of Z when X is 45. 45 minus that 5 over 5, that one is 10 over 5, which is 2. Now where does 2 lie in our bell-shaped curve? 2 can, between 0, 2 can be here, but because we are interested in those who lie beyond 40, now beyond 40, it means it is this area that you are seeing I've shaded here. Now how do you get that? Now for the normal distribution, the whole area below the curve is 1. That means that every half is approximately 5. So what you do is you get the area between 0 to 2, and then you say 0.5 minus the area you get between 0 to 2. Now when you go to the normal distribution table, you'll get that for 2 has got this value 0.4772. That implies between 0 to 2, that area is this. But first we are interested in this area, but the whole of this area is 0.5. So we are going to say it is going to be 0.5 minus this small white area here, and we get this. So your work is to work out the other question that are in the same question in the notes I've uploaded and compare your answer. I'm going to upload for you a normal distribution table for your reference. Thank you.